Hi, I'm Chirag and this is my project on shallow blister effect. I would like to start by asking a simple question followed by a seemingly impossible question. So, how do you move a shadow without moving the object? One would simply answer by moving the source of light. But what if we cannot move the source of light to the object or the screen on which the shadow is being projected? Give it a thought and we'll return to this in a while. Let's get started with the project. Shadows are so familiar to us that talking about them might seem trivial, but you might have guessed by now that this is not the case. The blurry edges of everyday shadows that we see are caused by the light source being extended objects. Light from different parts of the source is able to travel into the shadow region because they emanate from different points in space. The darker inner part of the shadow where no light can reach is called the umbra. The lighter outer part of the shadow where some light can reach is called the penumbra. Everyday objects illuminated by sunlight, such as trees and fences, can show cast shadows composed of umbra and penumbra, just like astronomical objects. Here I used a quite extended source of light for the shadow on the left, and on the right we see a shadow of my UBC card using a laser that does not show any penumbra. Consider shadows on a viewing screen of two objects, alpha and beta, illuminated by the sun or some extended source of light. Because of the angular extent of the source, each shadow has both umbra and penumbra regions. If alpha is closer to the viewing screen than the beta is, its penumbra is narrower than the beta. Suppose one of the objects is moved so that the penumbras of the two shadows overlap. In that case, the umbra of the alpha appears to bulge out towards the umbra of beta, giving a blister like appearance to the umbra of alpha. This is what happens when the two objects lie far from each other, and this is what happens when they lie closer. Summing up, when an extended light source such as sun illuminates two objects such that their shadows lie close to each other, such that the penumbras of the two shadows overlap, the shadow of one of the objects appear to bulge out towards the shadow of the other. This is called the shadow blister effect. Here we see that the object closer to the screen has its shadow bulged towards the shadow of the other object. The shadow blister has its greatest visual impact when the aspect ratio of equation 16 and 17 is large. This occurs when the angular radius of the source is large when the distance between the screen and the two objects is small or and the gap between the two objects is smaller. And this is just me trying to get the greatest visual impact. Diffraction is defined as the bending of light waves around the corner of an obstacle or an aperture. Diffraction can also cause shadows to be blurry, but the effect is rare in everyday life. Stated more carefully, diffraction itself is common in everyday life, but diffraction causing the blurriness of the shadow edges is less common. Diffraction is a wave effect where waves are able to bend around the corners of obstructions. First of all, diffraction is a weak effect that depends on the wavelength of light. Secondly, diffraction is a coherent effect that typically requires a nearly monochromatic beam, such as a laser beam, in order to become significant. Sunlight contains many colors that all diffract differently. As far as shadows are concerned, the net effect is that the diffraction effects wash each other out for sun or a white light source. Let's get back to the original question. How do we move a shadow without moving the object or the source of light? Let's look at a video that I shot 2 years ago, which left me confused. Is it the blister effect that's moving the shadow to and forth, or diffraction, or is it something entirely different? I leave it up to you. Thank you for your time.